Statistics, take a look at section 9.5, discussing two variances or two standard deviations and how it relates to the population. So we were given this one problem back in section 9.3 where we talked about men and women and talking. So once again, this accompanying data was given from a study. We're going to use a 0.05 significance level to test the claim that the number of words spoken in a day by men vary more than numbers of words spoken in a day by women. Okay, so we're going to use a significance level of 0.05, and the claim is that the number of words spoken by men vary more. So men words vary more than women words. So now what we're going to do is we're going to construct our hypothesis test based on this information. So if we think back, the first thing we have to compare to, and the table's set up like it should, but we have to always make sure when we're doing a varying, so basically we're talking about that variance, we want to make sure that the one with the larger variance is the first one. So we see 8,632.5, 7,301.2. So this is the larger number, so this has to be our first set, because once again, that kind of simplifies our testing procedure as we go about this. So we're considering the fact that we have our standard deviations, once again, are equal to, or in this case, so our null hypothesis, we're comparing our population, we can use standard deviation of 1 equals a population standard deviation. Actually, we should use variance. We're talking about varying of 2. Our alternative hypothesis would be talking about that the males, because they have the larger standard deviations, we're going to talk about that this first one has a larger. Now, is this truly larger is what we're testing towards, okay? So once again, if this was 7,302.1, it's still larger. That's why it's the first set, okay? Now we're actually going to test that this is larger within here. So in your calculator, okay, in that calculator, we're going to go menu, statistics, stat test, and we're going to arrow down to the F test. Okay, 2 sample F test, number 9 there. Sorry, I passed it. So 2 sample F test. In here now we have our actual statistics that are given to us. We don't have a list of data. So we're going to run our comparison here. Our first, notice it asks for the standard deviation, so 8632.5 with a number of 186. Notice this one does not ask for the mean at all because we're not testing towards the mean. Then we're going to go to our second standard deviation of 7301.2 with 210. Okay, so if you notice, I can kind of get this in right here, we see that we have our standard deviation of our first one, number in the first one, second standard deviation, number in the second one. Now our alternative, we want to come down here and we want to select that the first one is larger than the second one. Okay, and then we come in here and we get our values. So if I write my value down, my test statistic, I have my F test, so my F value is 1.398, and then my P value equals 0.009413. Okay, so we see our p-value is less than our significance level, so that allows us to reject the null hypothesis. Okay, so now that we reject the null hypothesis, we basically are stating that we don't have equality, that we're citing here, and our claim was that men's words vary more than women. So this means now that there is evidence to support the claim that men words in a day vary more than women words in a day. So basically, males have a wider vocabulary, right? Right, guys out there? Is it true overall? Well, it depends upon the male. There are some Neanderthals out there that don't belong in those categories, but there are some people who think they're over-intelligent and try to use all those big words. So it could go either way on the common sense explaining in which this could go into, but statistically this is what we start looking at within here. Take a look at one more, just so we can kind of see what to do with our stats, okay? So we're going to look at problem number 14. Okay, and I'm going to pause the video so I can write this out for you to see. Okay, now that I have my list all typed up or written out here, here we talk about longevity. It says listed below, or right here, are the numbers of the years that popes and British monarchs, okay, since 1690, lived after their election or coronation. Once again, this is based on a computer interactive data analysis by Lunn and McNeil, John Wiley and Sons. We want to treat the values as a simple random samples from a larger population, okay? So just because this really isn't a simple random sample, just because it's listed in a row, basically we're taking all the information from a given period in time, we can kind of treat it that way because this is all the popes listed to that point, once again minus the current ones after the publication of this book, and these are all the king and queens listed, or kings I should say listed, I don't know, king and queen, sorry, there's an and queens, you know, I guess I should state that in there, that we had since 1690, okay? What we want to do is we want to figure out, it says use a 0.05 significance level to test the claim that both populations of longevity have the same variation. Okay, so we're going to use a significance level of 0.05 for the claim that both have same variation. Okay, so it didn't matter if you're a pope or a king or queen, the amount of years that you were in there varied the same. Once again, some were longer, some were shorter. We see one didn't make it too long, so something must have happened there with that pope. Got elected, was so happy, jumped up and had a heart attack. Who knows? I guess we could research it to figure out, but I don't know offhand on what happened there. So I took the liberty of typing this into my calculator. If you notice, I have my pope, king, and then I have my list below. Now, one of the things we always talk about is we want to denote what is our first, okay? So we want to say, okay, which is our first one, which is our second one, because that really does tie into the fact that it shortens up the test, especially if we had to do it by hand and analyze critical values. And our p-values do help out somewhat, but we want to quick check this. So what we're going to do is we're going to go menu, statistics, and we're going to do a stat calculation, okay, on this. And what we're going to do is we're going to do a one variable stat, and then we're just going to start with the pope, okay? And basically what this pope list tells us is it tells us that we have a sample standard deviation of 8.96, okay? So I'm just going to go up here and I'm going to go sample standard deviation 8.96. Now I'm going to do this again. I'm going to go Menu, Statistics, Stat Calculations, one variable, one list, and now I'm going to bring in my king. I'm going to come down here, and then I see king and queens have a sample standard deviation of 18.60. Okay. So once again, we want to make sure that, if you see right here, it's that SX, SX. So we want to make sure, that we want to have the larger one be our first set. So what we're going to do is, this is going to be data set 1, this is going to be data set 2. Okay? So now we're going to come down to our null hypothesis. Our null hypothesis is going to deem that our variance of our first set equals the variance of the second set. Our alternative, once again, both have the same variation as our claim, so that's a null hypothesis. That means the alternative hypothesis has to be everything that is not this. So now we're going to go with that two-tail not equal to on here. And then now we're going to have to test our claim. Okay, so we're going to have to go and test our claim. So we could go through menu statistics. If you notice, there's a stat test, and we could do our two-sample F test right here. Okay, so I'll do it this way. I don't have to go over to the other one, and you can see that personally I like the other way better. We have our data, so we're just going to pull our data sets in rather than write out all this information here. It's just going to have that automatic calculation. Remember, the king and queens was our first one, then Pope was the second one. Frequencies, we're not doubling any lists. Alternative hypothesis. So our alternative hypothesis was not equal to in here. And then down here it asks for, where do we want this to do? Do we want to draw out our graph so we can actually have our graph drawn out in here? We can select this to shade the p-value. It could give us a graph on this and everything else. Not really interested in this overall. Just kind of want to get through my value. So if you notice right here, it gives me my f value to be 4.31, my p-value to be 0.00225. Okay, so I'm going to come here and I'm going to go for my test statistic. F equals 4.310. My p-value is 0.00225. Okay, so if we look at this right here, we see that we have to reject the null hypothesis. Okay, once again, this p-value is really low, so remember, if the p-value is low, the null must go. So we reject the null hypothesis. Because we reject the null hypothesis, we're saying that these variances are not equal. Okay, so if these variances are not equal, there is sufficient evidence to reject the claim that both populations of longevity times have the same variance. So there is sufficient evidence to reject the claim that both populations have longevity times, so longevity varying the same. Okay, so once again, we're showing signs that it's not equal to, but our claim was towards that they're both, so it's a null. So once again, there's sufficient to reject that claim within here. So once again, it's all that wording that goes into it. So do realize that we don't do this test often. It's not a lot of times we talk about variance, but there is times when it is important to reference towards and that's where we're going to use this f-test. So do realize that a lot of the procedures, a lot of things that we'll be working with are requiring that you do remember how to work with the overall which test it is and what you're going to be applying at that point in time.